Day 425 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3333. Find the original type string 2. The difficulty level is hard, but don't even worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Alice is attempting to type a specific string on her computer. However, she tends to be clumsy and may press a key for too long, resulting in a character being typed multiple times. You are given a string word which represents the final output displayed on Alice's screen. You are also given a positive integer k. Return the total number of possible original strings that Alice might have intended to type if she was trying to type a string of at least size k. Since the answer may be very large, return it in modulo 10 to the 9th power plus 7. All right, y'all, so that may seem a little bit confusing at first, and I would suggest if you have not been following along with this channel or you missed yesterday's problem, go ahead and check out yesterday's problem because it was find the original type string 1. We did that yesterday. It's an easier problem than this, so you could get some practice beforehand before you try to attempt doing this problem. Now, with that being said, y'all, let's get into the examples just so we can make sure that we are doing this problem correctly. So in example 1, we have the input word equals a string AA, BB, CC, DD, K equals 7. The output is 5. Explanation says the possible strings are AA, BB, CC, DD, AA, BB, CCD, AABBCDD, AABCCDD, and ABBCCDD. Now, these are all of the possible combinations that Alice may have been trying to type that have a length of at least 7, right? So as you can see, we start here. This is the full string. This has a length of 8, right? It has to be at least 7. 8 is greater than 7, so it still works. Then all of these, that's when we are deleting one of the duplicates because it says right here, she may be clumsy and may press a key for too long, resulting in a character being typed multiple times. So we have to go through each one of these characters and see if there's any duplicates, and we need to take into account that she may have not typed the duplicate on purpose, right? She may have just been being clumsy. So we have to go through all of these characters and just see how many possible original strings that we can create that still have a length of size k, which in this case is 7. So we can delete one of each character. As you can see, each character in the original string, there's 2 of each characters. So for each original string that she may have been of at least 7 that she may have been trying to type, we could just delete one of the characters for each duplicate, right? And that'll give us our final output of 5 when we include the full string, meaning maybe she did the duplicates on purpose, right? So in this one, we have the full string. Then this one, we delete one of the D's. This one, we delete one of the C's. This one, we delete one of the B's. And this one, we delete one of the A's. Those are the only possible combinations that we can create that have at least a length of k, right? Because we're starting at a length of 8. So if we want to have at least a length of 7, that means we're only allowed to delete one character each time, and we can only delete a duplicate because if it's not a duplicate, that means she meant to type it and she didn't hold the key for too long. That just means it's exactly how it's supposed to be. So just in case that didn't make sense, let's go ahead and take a look at example 2. Example 2 it's a little easier just because there's only one combination. So in example 2, the input word equals the string, same string, AA, BB, CC, DD. This time the count is 8, the output is 8. The explanation says the only possible string is AA, BB, CC, and DD. And that is because the K equals 8. So since K equals 8, we're not allowed to delete any characters, right? Because it says if she was trying to type a string of at least K. which means she was trying to type a string of at least 8 characters. This is the string of 8 characters. If we delete any of the characters, even though they're duplicates, then we won't be at length 8. So we can't delete any characters. We have to keep all of the characters included, and there's only one output for that, which is the original input string right here. So let's look at example 3 just to really bring this home and make it make sense to everybody in case some people are still confused. So in example 3, we have the input word equals a string AAA BBB K equals 3. That means she was trying to type a string that was at least 3 characters. She may have been clumsy and held the key for too long and made some duplicates. This time the output is 8. Let me copy and paste this over here so we could so y'all could get a better visual representation of what she may have been trying to do. So this is what she did. This is what she typed, and this may be what she wanted to type. We don't know, but we trying to find out what are all the possibilities of what she may be trying to type. So maybe she want to do AABBB, right? Or maybe she just want to do ABBB. Or maybe she want to do AAABB, or she want to do AAAB, right? And this, and this right here will give us 1, 2, 3, 4, 5, right? So then maybe, but remember, K is equal to 3, so it has to have at least 3 characters. So maybe she just want to do AAB, or maybe she want to do ABB, right? We won't know. And this would be 1, 2, 3, 4, 5, 6, 7. So finally, maybe she wanted to do, we could put this one right here, but maybe she wanted to do AABB. You know, we don't know what she was trying to do. We just know that she was trying to type some A's and type some B's. These are 1, 2, 3, 4, 5, 6, 7, 8 different possible combinations that she may have been trying to type. We don't know, but these are 8 combinations that could be. They all have at least a length of 3 because K equals 3. So we just had, but since there's 8 different possibilities, we're just returning the output, which may be 8. So I hope that made sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Let me just bring this up here just so it could make a little bit more sense, just in case people are still confused. Let me just line these up so you can see what we did. But we went 3 A's and 3 B's, then we went 3 A's and 2 B's, then we went, let me just put this in order for y'all, then we went 3 A's and 1 B, then we did 2 A's and 3 B's, then we did 2 A's and 2 B's, then we did 2 A and 1 B, boom. Then we did 1 A and 3 B's, and finally we did 1 A and 2 B's because we had to stop here because the length has to be at least 3, and it has to include at least one of each character, right? We can't just do all B's. We can't just do all B's or all A's because she typed the A and she typed the B, meaning she wanted to type those characters. We just don't know if she wanted to type as many characters as she did. So these would be the 8 different possible different combinations that she may have wanted to create. So I hope that made sense to y'all. And now that we understand that part, let's get into the fun part, the actual solution. Y'all, solution is not that difficult at all. So let's get started. Now, the first thing we're going to do is we're going to define our module constant for all modular arithmetic that we're going to be doing. So for that, we can say let mod mod equal 1 underscore 000 underscore 000 underscore 000, or excuse me, 007, right? And that is going to get us this right here. Boom. Then we could come underneath that, and remember, this is outside of the function. It's not inside the function. It's in the class, but outside the function. It's not inside the function. Then we're going to do our modular multiplication to safely multiply large numbers under mod. So we could say at inline, open up the parentheses, underscore always. Then we're going to come underneath that, and we're going to say func open up the func mod, mul for multiplication. Then we're going to open up the parentheses. We're going to say underscore a colon, that's going to be integer, comma, underscore b colon, that's going to be an integer as well. And we are going to return an integer just like that. Boom. And we're going to say return int, open up parentheses, open up some more parentheses. We're going to say int, open up some more parentheses a, come outside those, we'll see times. Then we're going to say int, open up parentheses b. Then we're going to come outside these two parentheses right here. We're going to say mod int 64, open up the parentheses, and we're going to pass in mod just like that. Boom. Now we're going to do our modular addition, which is going to, and it's also going to handle overflow for us, this next function. So this next function is for the modular addition. Once again, we'll say at inline, open up the parentheses, underscore always, come underneath this. We're going to say func. We call this one mod add, open up the parentheses, underscore a colon. That's going to be int, comma, underscore b colon. That's going to be integer as well. Come outside of that, it's going to return an integer. Then we're going to open up the brackets. Now we're going to say let sum equal a plus b. Come underneath that, we're going to say return sum is greater than or equal to mod. And this is going to return a Boolean. So if the sum is greater than or equal to mod, we're going to say question mark. If that's true, then we're going to return sum minus mod. Else, we're going to say colon. We're just going to return sum. Boom. Now, we're going to do the same thing for subtraction. We could kind of copy and paste this, but we're going to change it around, though, for subtraction. So we could say mod. This time, we're going to say mod sub right here. It's going to have underscore a colon integer, underscore b colon integer. Is going to return an integer. This time we're going to say let diff equal a minus b, and we're going to say return diff is less than, so we're going to say return diff is less than 0. And if that's true, once again we're going to say, or not once again, but over here we're going to say diff plus mod this time. And else, if that's not true, we could come over here and we could just say return diff. Boom. Now we could get into the main function right here. Boom. Now, first thing we're going to do is we're going to convert the input word into an array of characters. So we're going to say let chars equal an array, open up the parentheses, and pass in word just like that. Now, we need to build segments of consecutive same characters. So we declare a variable called segs. We'll set that equal to, open up the square brackets, pass in 1. And we're going to say for I in 1 dot less than chars dot count. We're going to open up the brackets and we're going to say if chars square bracket I equals chars square bracket I minus 1, that means we found a duplicate. So we're going to open up the brackets and we're going to say segs square bracket segs dot count minus 1. Come outside of that, we're going to increment that by plus equals 1 and extend the current segment. Then we're going to come right here and we can say else. So if they don't match, we can say segs dot append, open up the parentheses 1, and we're going to start a new segment. Now we need the total number of segments. So we can come underneath this. We'll say let segment count equal segs dot count. Boom. Now we need to compute the total combinations by multiplying all segment lengths. Each segment of length s has s ways to choose its contribution. So for that, we're going to say var total. We're going to set that equal to 1, and we're going to say for s in segs. Then we're going to open up the brackets, and we're going to say total equals mod mul, open up the parentheses, total, comma, s, just like that. And if k is less than or equal to the number of segments, we can form all valid combinations directly. So for that, we come underneath this, we can say if k, k is less than or equal to segment count, we could just open up the bracket and we could say return total, just like that. Now we're going to use some dynamic programming, and that's going to equal the number of ways to form a string of length j using first I blocks. So for that, we could start our dynamic programming array by saying var dp equals an array of integers. Come outside of that, open up the parentheses, repeating colon 0 comma count colon, that be k. Boom. Then we need a base case, which one way to build a string of length 0, so we could just say dp square bracket 0. We could set that equal to 1 for our base case. Boom. Now we are not done yet because we still need to process each segment. So for that, we come right here, we say for I in 0 dot less than sign segment count. We're gonna open up the brackets. We need to find the max number of characters we can use from this segment. So we're gonna say let max add equal segs square bracket I. Now we need our prefix sum array to optimize range sum queries for dynamic programming transitions. So we could come underneath this and we can say var prefix, and we'll set that equal to an array of integers. Come outside of that, open up the parentheses, is going to be repeating colon 0 comma count colon, that's going to be k plus 1. Then we're going to come underneath that and we are going to say, sorry y'all, I'm just trying to figure out why prefix is blue like that, but oh well, it doesn't matter. We're going to say for j in 0 dot less than k. We're going to open up the brackets and we are going to say prefix square bracket j plus 1. Then we're going to say equals mod add, open up the parentheses, prefix square bracket j, square bracket j, comma dp square bracket j, just like that. Now we need to build a new dynamic programming array for this segment. So for that, we can come underneath this for loop and we're going to say var new dp, set that equal to an array of integers, open up the parentheses, that's going to be repeating colon 0 comma count colon k. Come underneath that and we'll say for j in, open up the parentheses, I plus 1, come outside of the parentheses, dot less than k. We're going to open up the brackets and we'll say let left equal max, open up the parentheses, 0 comma j minus max add. Come underneath that and we are going to say new dp square bracket j equals mod sub, open up the parentheses, prefix square bracket j, come outside of that, comma prefix square bracket left. Boom, just like that. Now we could come underneath this, and we need to move to the next segment. So we could come underneath this, and we can say dp equals new dp. Boom. Then we could come underneath this, and the sum, or these, the sum of dpj, where j is greater than or equal to segment count and j is less than k, these represent the combinations that are too short or invalid. So we could say, meaning that they're less than k. So we could declare a variable that is less, called less than k, and we'll set that equal to 0. Then we're going to say for val in dp, we're going to open up the brackets, and we're going to say less than k equals mod add, open up the parentheses, less than k, comma, val. Then we still need to subtract the invalid combinations from the total to get the valid strings of length k. So for that, come underneath here, and we could just say return mod sub. For subtraction, open up the parentheses, passing total, comma, less than k. And that should be all she wrote, y'all. Let's go ahead and give this a run. Make sure it runs properly before we submit it. It's taking a little while here, so we already know what that's gonna go through. So let's see. What does that say? So, okay, so let's see where we went wrong. Oh, so this should have, sorry y'all, this should have 2 underscores. All of these should have 2 underscores. Let's go ahead and run it again. See if that fixed it. Let's see. Okay, cannot find A in scope. Oh, this should have a space right here. Dang, we're not starting off good. We're getting bugs early in our first line. Our second and third line of code is already typos. Let's see what happens this time. Let's see. I don't know why it's taking so long. Error compiler. Let's see where we went wrong here. So let's see. Sorry about this, y'all. Mod N64 mod. It says then it cannot find a less than k. Well, let's just fix this first. That's an easy one to fix. Okay, now let's see what's going on up here. Let's see, let me see, y'all. Or was that it? Was that all that needed to be fixed? I don't know. I don't think so, though. Let's see, y'all. What is... Oh, I'm sorry, y'all. I see what's going on. So this should be right here. This should be N64. Let's see if that does the trick. Hopefully that does the trick. We'll see. And there it is, y'all. Finally, y'all. That's what I'm talking about. So let's go ahead and submit it. Let's make sure it's still accepted after we submit it. Look at that, y'all. 270 milliseconds beats 100% of users with Swift. That's what I'm talking about. Those are the numbers that I like to see, y'all. I know it's a lot to take in today, but we made it. We got through it. So with that being said, y'all, before we leave, make sure you get one more look at the code. These are the inline functions right here. Then let's go down to the main function. This is the top part of the main function. Boom. This is the middle part of the main function. Boom. And this is the, we got more. This is the second half of the middle portion of the function, main function. And then this is the end of the main function, y'all. And with all that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.